Algebra 2, Lesson 6 from the Saxon math book. Our objective is to how do you solve equations with decimals and how do you solve consecutive integer problems. We'll start off with the first part of that there with how do you solve equations with decimals. Well, you can either work with decimals, or if you're like me and you don't really want to work with decimals, you can kind of get rid of them. In order to get rid of them, what you have to do is you have to think about which one has the most places to the right of the decimal place. Notice this one here just has 1. This one has 2 places to the right decimal. And this one has 1, 2, 3 places to the right decimal. So then what I need to do is I need to multiply both sides of the equation by 1,000. I chose 1,000 because this one had 3 decimal places. If the largest one had 2, then I would multiply it by 100. If the largest one just had 1, then I would have multiplied by 10. But just remember, whatever you multiply one side by, you also have to multiply the other side by that. So multiplying both sides by 1,000, hippity hoppity, 1,000 times 0.003 is just going to give me 3x, plus, same thing's going to happen here, move the decimal 3 places to the right, so it's going to be 1, 2, 3. So plus 400 is equal to, same thing's going to happen on the right, 1, 2, 3, 2,050. So now we just need to subtract minus 400 from both sides. And I guess I should point out, notice at this point, I no longer have decimals in there. I'm just working with whole numbers. So for me, it's a little bit simpler. You can kind of decide if it's easier for you or not. So then this is going to give me 3x on the left. It's going to equal to 1,650. Dividing by 3, because those two are multiplying. The opposite of multiplying is dividing. And you'll get x is equal to 550. Now along those same lines as if you had fractions. And I don't know about you, I like fractions even less than I like decimals. So what I want to do is I want to try to get rid of these fractions. So the first thing I'm going to do is I'm going to convert my mixed numbers that I have here into improper fractions. Hopefully remember how to do that. If not, I'll try to remind you real quick. You multiply the bottom by the big number, or 5 times 4 in this case, which would give you 20, and then you add the numerator to that. So this is going to be 21 over 5x plus, same idea, 4 times 1 plus 3, 7 over 4, is equal to 3 times 5, 15 plus 1 is 16 over 3. Now the next thing we need to do is over here on the right, we need to find the LCM of 5, 4, and 3. Saying lots of things. The LCM is the least common multiple. And I say a 5, 4, and 3 because those, notice, are my 3 denominators. I have a 5 as a denominator here, 4 as a denominator here, and 3 as a denominator here. So I'm going to find the smallest number that all 3 of these are a factor of. One way to do that would just be to multiply all 3 of them, and in this case that does come out to be the least one. So our LCM in this case is equal to 60. So what I need to do is I need to multiply this entire equation, the left and the right hand side, by 60, my least common multiple, and that will get rid of all of my fractions. So multiply the left hand side by 60. I'm going to go and write this as just 60 over 1. And the right hand side by 60 over 1. So then if I use the distributive property here on the left, hippity hoppity distributive property, I'm going to write this out one more time just to make it a little bit simpler as we simplify. So what we want to do here is simplify each of these sets of fractions right there. So I notice that 5 goes into 5 one time, and 5 goes into 60 12 times. So then I just need to multiply 12 times 21, which is 252 over 1x, plus, I notice 4 goes into 4 one time, and 4 goes into 60 15 times. So I need to multiply the 15 and the 7, which comes out to be 105. And then on the right, I notice that 3 goes into 3 one time, and 3 goes into 60 20 times. So I just need to multiply the 20 and the 16, which comes to be 320. So again, now you can see that I have no more fractions. I have bigger numbers, but I don't mind bigger numbers, especially when they're not fractions. So going through and finishing solving here, I need to subtract 105 from both sides. And I'm going to have 252x is equal to 215 divided by 252. And because I just made this problem up completely off the top of my head, that number doesn't simplify down nicely. But our final answer is going to be x is equal to that 215 over 252. So honestly, a pretty number, but simpler for sure. Okay, now I told you I would try to give you another LCM problem, least common multiple problem. And we're trying to find the least common multiple of 4, 12, and 5. So what I want to do is I kind of want to break down and find the prime factorization of 4, 12, and 5. Well, 4 just goes into 2 and 2, and those are both prime, so I'm done there. 12 goes into, 2 and 6, and then 6 breaks down into 2 and 3. And then 5 is actually prime itself. So then what I need to do is I need to look at each of these. In order to get the 4, I need to have 2 2's. In order to get the 12, I need to have 2 2's and a 3. In order to get the 5, I need to have a 5. So I'm going to multiply those together. So I'm going to say 2 times 2 times 3 times 5. So notice the 2 times 2, that gives me the 4. The 2 times 2 times 3 gives me the 12. And the 5 will give me the 5. So just multiplying those together, 3 times 5 is 15 times 4. The LCM of this one is going to be 60. That's just coincidence that the LCM came out to be 60 earlier as well. So let's go multiple of this one is 60. So hopefully that'll make a little bit more sense. If not, ask for clarification later. Alright, consecutive integers. Before we jump into a consecutive integer problem, we need to look at what the word consecutive integers mean. If I said I worked out for 5 hours consecutively, which is false, I never do that, but consecutively means 5 hours right next to each other. And then integers are numbers like 1, 2, 3, 4, 5, or -2, -3, -4. So when we say consecutive integers, we're talking about integers that are next to each other. Now, sometimes in these problems they'll say consecutive odd integers or consecutive even integers. Consecutive even ones would be like 2, 4, 6, because those are the integers that are even, that are next to each other. So just kind of make sure you understand what's going on. So now let's just jump into this crazy word problem and don't freak out as we read it. Find 3 consecutive odd integers such that 6 times the sum of the first and the third is 28 greater than 8 times the second. Exactly what I thought. What? So first of all, realize what we're trying to do is we are trying to come up with 3 consecutive odd integers. So just for now, let's call the smallest of those n. And that is not what I wanted to happen. Let's call the smallest of one of those 3 consecutive odd integers n. So if you want to think about odd integers, maybe it's 3. If I want to get to the next odd integer, would be 5. I would need to add 2 to that. So the next consecutive odd integer is going to be n plus 2. So from here to here I'd have to add 2. And the next one after that would be 7. So to get from 5 to 7 I'd have to add 2, or to get from 3 to 7 I'd have to add 4. So my third consecutive odd integer would be n plus 4. So notice now I have 3 consecutive odd integers. This is my first one, this is my second one, this is my third one. And I've named them thus, thus, and thus. And notice I've used just one variable for all of these, n. So that I'm able to solve these with just one equation. So now we need to get into the rest of this mumbo jumbo. It says such that 6 times the sum, so let's say 6 times the sum, means parentheses, of the first and the third. So the first one is n, plus the third one, which is n plus 4, is 28 greater, so I'm going to say plus 28, then 8 times the second, 8 times the second, and the second one is n plus 2. Pause it if you need to, think about what I just wrote, should make sense. Now we just need to go about solving this. Simplify inside parentheses as much as we can first. This is going to be 6 times 2n plus 4 plus 28 is equal to, I'll go and distribute on the right, 8n plus 16. Distributing on the left, this is going to give me 12n's plus 24 plus 28 is equal to 8n plus 16. Combining like terms on the left, 12n plus, what is that, 32, 52 is equal to 8n plus 16. I'm going to subtract 8n, subtract 52, end up with 4n is equal to a negative 636. Dividing by 4, I get, coming up over here, n, and somehow I switched to lowercase n's instead of uppercase n's. I apologize for that. N is equal to negative 9. Now that's not my answer, that's just the smallest of the 3 consecutive odd integers. I'm trying to look for the 3 consecutive odd integers. So negative, no idea what I did there, negative 9 is my smallest one. Then I'm going to say negative 9 plus 2, which would be negative 7. And then negative 9 plus 4, which would give me negative 5, are my 3 consecutive odd integers.